So this question is a diagram question. This diagram looks a bit weird to me. It looks like maybe I see, so I definitely see frequency as my y-axis. I see values in increments of 10 as my x-axis for both. Obviously, this is data set A, this is data set B. And I see these vertical lines here, which I think should represent like bar graphs, right? So this is actually like a histogram. It's just a weird looking histogram because nothing is shaded in. So data values between 10 and 20, looks like there's 5 of them. Between 20 and 30, there are 3 of them. Between 30 and 40, there are 2 of them. Between 40 and 60, there's 1. And between 60 and 70, there's also 1. For data set B, between 10 and 20, there are 5, so that matches actually. Between 20 and 30, there are 3, so that also matches. Between 30 and 40, there are 2, so that also matches. And then there's nothing else left. There's no other vertical lines. So let's read the question to see what's going on here. The 2 histograms show the distribution of data set A and data set B respectively. Data set B is the result of removing the outlier from data set A. Okay, so yeah, so it looks like these data points have been removed. They're not present here in data set B. Which of the following statements about the means of data set A and data set B must be true? Or not must be, but is true? Well, obviously, the mean value for data set A has to be larger than the mean value for data set B, right? So that's just has to be a very obvious thing. If we're removing data points that have higher value, then the mean is going to be impacted, right? So the mean will be lower for data set B than for data set A. Let's try choice A. So it says the means of data set A and B are the same. Definitely not. Choice B, the mean of data set A is greater than the mean of data set B. Definitely true, right? I'm not going to even read any other answer choices. That has to be the right answer.